In our third circle theorem video, we're going to be looking at this situation, sometimes called a bow tie situation, where we have these two angles up here. They're the same size, so these are staying at 52 degrees in this example. Or if you start moving one of these points, they both shrink down, but they stay the same size. Now, by default, we never assume that there's a radius or a diameter going on in the situation. We're not necessarily passing through the center. We might, but we don't have to. And this situation is a bit weird to understand. People talk about the word subtended. We don't need that, so you might have heard something like this description: angles at the circumference subtended or the same arc or equal. You don't need the word subtend. You don't need to know what it means for circle theorems. It doesn't matter. So this description is much better. Angles in the same segment are equal. Now, my philosophy is only use the underlined words because it makes things shorter and easier to understand. Same segment angles equal. Right. What does that mean? Let's try and understand it. So in the situation here, we've got two segments. Where are the segments? Well, if we join kind of across here with a chord, we don't normally see that chord, but if we do, we've split our circle into two segments. What's a segment? Well, a segment is an area between a chord, laying a line across the circle, and the circumference. So this here, this yellow one, that's a segment. It's called our minor segment. It's the little one because of given where we've just put a chord. And this one up here is our major segment. And in that segment, we've got these two angles, these two 52-degree angles, and they are the same. And no matter where we drag those points up here, they stay at 52 degrees because of where this segment has been cut, because these points are from the two sides of the chord that's cutting the segment. That's where the name comes from, same segment angles equal. And I would always, in my head, think of it as SSAE, for same segment angles equal. So that's my third circle theorem. The complexity that appears in this particular circle theorem is people mistake it for a special case of Katka. So this situation here, people look at that and go, same segment angles equal. They're the same size. No, they're not the same size. They don't look the same size. No, that's Katka. This is center angles are twice circumference angles here. There's a center angle, there's a circumference angle. This one's clearly bigger than that. This is Katka. Over here, this is SSAE. Okay, that's our third circle theorem done. If you enjoyed this video, you've got a comment, please question, and see more like it, please subscribe.